Good evening, good afternoon, good morning from wherever you're joining us from today. My name is Sarah and I'm the Program and Event Manager at the Reactor in Sydney. Welcome to another Microsoft Reactor Sydney livestream event. Tonight I would like to welcome Dave Glover. Dave works at Microsoft and is a passionate software developer. Over the years, he has covered a broad range of technologies from Windows and mobile, web dev, IoT, communications, and cloud-centric computing. This evening, you will learn within this hour how to build and debug C# .NET Core IoT apps running on your Raspberry Pi. This session will be approximately 60 minutes with about 10 minutes at the end for questions. So do put them in the Q&A throughout. And Dave said he mentioned he will try and answer as many as possible. But if we don't do throughout, we will answer those questions at the end. And at the conclusion, we'll also be sharing a link to our survey, which helps curate our topics for future. So if you can take 5 minutes to answer those survey questions, that would be awesome. And we'll also put this one up on YouTube. So there will be an on-demand version within 24 to 48 hours after the event. So if there's anything you missed today, you can refer back to that. But for now, I'd like to hand the floor over to Dave to begin. So Dave, over to you.
Hey, thank you very much, Sarah, and welcome everybody. Do feel free to add into the comments where you're sitting and and watching this event, so you can try out the ability to go and post questions into the Q&A. So just pop a little note there just saying where you are. It's always useful to know where people are. I'm based in Sydney, Australia, and it's 6 p.m. here and we've just gone off daylight saving, so winter is on the way. So I'm what's known as a cloud developer advocate, and my role is really very focused around IoT and Internet of Things, and I've really been a developer really most of my life. And so I do a lot of microcontroller development, a lot of C development, a fair amount of C#, not as much C# as I used to, and a good amount of Python as well. So they're kind of my main three languages that I do. And I'm using those languages mostly in the context of devices. So it could be Raspberry Pis, it could be an Azure Sphere, it could be an Arduino board, or those types of things. I've got a GitHub, which is generally teeming with new projects and new ideas. So if you head to github.com/gloveboxes, so it should be a reasonably easy one to remember, given my last name's Glover. You can follow me on Twitter, so at @dglover. As Sarah mentioned, this session here is really around Raspberry Pis and using C# and .NET. So this is really covering .NET Core and Core.3 and .NET 5, which is the new name. We've dropped the Core moniker for version 5. We're going to be looking at how you can go and build IoT apps. Basically how you can access hardware is really the guts of what that's about. And we're going to be looking at IoT Plug and Play, which is something reasonably new off the block. And we're going to show how that kind of works with IoT Central. And you'll kind of get a bit of a sense of how that works. Now, super happy for you to ask questions as we go through the session. So I've got the Q&A live there, and I will do my utmost to keep an eye on what's going on. And so in terms of what the agenda is, we're going to be looking at, we're going to be using .NET Core. So sorry, these labs that you could be using, you can either go and build with .NET Core 3.1, or probably more preferable using it, given it's now released, is .NET version 5.0. And the thing I'm going to talk about is the IoT libraries that are available for .NET Core, which are an open source set of libraries from Microsoft and the community, and we're just going to talk through those. We're going to talk a bit about prototyping, so kind of some of the tips and tricks I use for prototyping on Raspberry Pi. I suspect, like a lot of you, my real core skills are software development, and I know enough hardware skills to be dangerous. So I tend to use kind of prototyping boards rather than actually kind of getting really down with the nitty-gritty. So I'll explain about how that goes. So this session is based on which I'll put in the chat, on my GitHub. and I've just pasted that into the announcements. That's the link for the set of labs, and as you can see, it's about Raspberry Pi and .NET Core, and I'm going to be using a couple of styles of devices. Now, I've also got some useful tips and tricks for running Ubuntu, which is becoming very fashionable at the moment, running that on Raspberry Pi, particularly the Raspberry Pi version 4s. I wouldn't really recommend it below that. What I've got up here is some tips and tricks that I kind of gathered as I went through and kind of learned the hard way, and I've kind of gathered these tips and tricks. Now, these tips and tricks you will find in that link that I posted before. You'll see, in fact, down here, the tips and tricks. So that's what that is. And you'll see that there's just stuff there about setting up. Personally, what I do when I'm running a Raspberry Pi version 4 is I boot from USB 3. And the performance is really good on that. I use a fast USB 3 flash drive, in fact, and I get more than ample performance. You can see that I've got a bit there about setting up Wi-Fi, setting up booting from USB. I tend to overclock my Raspberry Pi version 4. If you do that, you must put a heatsink on your Raspberry Pi 4, otherwise you won't fry it per se, but what will happen is it'll just throttle. It'll get too hot, it'll throttle, and there's no point in overclocking it. It's just throttling the whole time. And the last bit I want to show down here, which is super important, if I can find it, yeah, is how to set hardware permissions for your IoT core applications. So one of the things you want to do almost invariably is to be able to access devices that are sitting on the I2C bus and devices that are sitting on SPI. And in here you'll see this is a good example of how you're going to enable access to ITC, which is the interchip to interchip communications. And if you don't do that, you will not be able to access the hardware, and you'll kind of bang your head against the wall and say, why did it work on his machine and it didn't work on mine? So you need to look at that. And the same deal is there for SPI. And probably for GPIO too, for that matter. Actually, maybe not so much for GPIO. As you can see in there, I also run quite a few other things on my Raspberry Pi, so you can absolutely extend out your .NET 5 or .NET Core 3 applications. I'm running Azure SQL on the edge. So we've actually got a build of SQL, Microsoft SQL, which is built for ARM, which is running in a Docker container, and it is staggeringly good. So you will see information there. Plus, if you scroll down a bit further, I think I've got down there for MySQL as well. So that's just some useful tips and tricks for building and getting started for building apps on Raspberry Pi if you decide you want to go and run Ubuntu. I personally use Ubuntu 20.10 on Raspberry Pi because it supports boot from USB 3. So it kind of makes a nice, easy life. Okay, so the next thing I want to talk about is the .NET Core IoT libraries and development. So we have a set of libraries that are, as I said, they're all open source, and I'll show you where those are in a moment. And they essentially come down to the main. If you look at actually starting in the orange, you'll see that there are some basic platform drivers for things like GPIO, for SPI, for pulse width, for ITC. And then we have these things called device bindings, and they sit on top of those platform drivers. So we've got analog converters, digital logic, blink LEDs, turn motors on, measure the temperature, humidity, gas levels, and things like that. Now these libraries are supported on x86 and x64, on Windows 10 IoT and Linux. So I'm going to be obviously showing you on both Linux 32-bit. So I'm running Raspberry Pi OS 32-bit, and the ARM 64-bit I'm going to show you will be running on Ubuntu 20.10 64. So those are kind of the drivers. Now, the link down the bottom there, which is github.com/.net/IoT, is where you'll find the drivers. And I'll just bring up my browser, And yes, okay, cool. So this is the main link up on GitHub. And you'll see there's a whole lot of information on here. Now, what you need to do is you need to go into source. And then when you go into source, you go into devices. And in devices, you will find almost most of the common, I would say 80–90% of the common sensors that you will need that have already got .NET Core drivers for them already written. And you can find them in this library. So, for example, this ADS15, from memory, it's a analog to digital converter. If you've done much around various projects, you almost certainly would have done things around the BMP 180 temperature and pressure sensors and things like that, or the BMP or BME 280s. Really common temperature sensors and things like that. But you'll see stuff there for driving motors. One of my favorite ones down here is the SenseHat. So if we go click on that, there's probably there isn't an image, but that's the Raspberry Pi SenseHat, which has got a built-in 8x8 LED matrix. It's got an accelerometer on it. It's got temperature, humidity on it. It's got buttons on it and things like that. So again, really useful ways of getting up and running. So you can see there's quite an extensible set of drivers. Hey, look, you can even go and drive your NeoPixels and stuff like that. And then if you scroll down that list a bit further, you'll see that it's been broken out into categories. So you've got accelerometers, gas meters, liquid meters, light meters, barometers, infrared, etc. So you can see there's lots of different sensors that are covered in there. And really, the goal of the team has to be to build the ones that we think most people are going to want, at least to kind of get up and running with. Alrighty. Okay, so the other source of content, and particularly device drivers, if you don't find it up there in this repo. So just to be clear as well, so this repo that I put up here, this is a Microsoft-inspired community repo. So we absolutely look for contributions as well. And if you go down through here, there is a whole guide on how you can contribute into that repo of device drivers, should you feel the urge. The other place to go is NuGet. And NuGet's got a stack of, you'll find a stack of libraries on there for Raspberry Pi and .NET Core. And again, that can be just a treasure trove of libraries, device drivers, and things like that. Now, invariably, you're going to find you're in a situation where you may not have the device driver that you wanted. That's sitting in those repos, either up in NuGet or sitting in the .NET Core IoT library repository. And the approach that I've taken, and just kind of give you a bit of a sense of what direction I go when I need to do this, is you might have a particular sensor or an actuator that you need to go and build a driver for. And you'll find that most of the time, actually, they're not that complicated. And most silicon providers, they will provide a C-based driver. Now, you may not be able to write C, but you can almost certainly, if you're doing C#, you'll almost certainly be able to read it. And it's just a matter of figuring out what's going on. You can see generally be a core to an I2C driver or a SPI driver. And then the rest of it's typically just around bit manipulation. So that's the typical approach that I take. I also go hunting for the data sheets, and they can be quite useful just to understand a bit about kind of what the expected behavior is. I very rarely do I ever hook up an oscilloscope. I can generally get by with the data sheet and looking at the C drivers. And the other trick that I use, if I'm really desperate, is I'll look for other platform implementations. Things like Arduino, for example, or you may find they've been written in Python. And they can be quite good, useful reference implementations for when you want to migrate across to C#. And I've certainly pulled across a lot to C#. They run beautifully. They really do work very well. As I mentioned before, we've got a series of platform drivers. So we've got support in there for SPI, so serial parallel interface, for I2C or I2C, however you like to say it, pulse width, modulation, and GPIO. So those are the kind of like the core components that you'll need if you're going to go and write your own device driver. Now, I want to put in a bit of one little proviso in here. If you do try and lift a device driver from something that's more real time, like let's say an Arduino or an Azure Sphere or Cortex M4 or whatever it might be, then those platforms, the timing is highly deterministic. A Raspberry Pi, when you're running the Raspberry Pi operating system or Ubuntu, is not a real-time operating system. So if you were trying to shift a device driver, that depends on really specific timing. It's probably not going to work very well on the Raspberry Pi unless you're super keen and you want to go and start doing some kernel development on the Raspberry Pi. And for most of us, we probably don't want to do that. So just keep that in mind. So most stuff will port across super easy. Keep in mind, if you just need to flick on a GPIO and turn on an LED or set a chip select bit or something like that, absolutely fine. If you've got a sensor that requires very fine grained control and you need to be able to flick that GPIO on and off super quick and at a predictable rate, then not so good on Raspberry Pi. What I tend to do if I do need that, by the way, is what I would do is I'll kind of put a motherboard, a mother chip on there, something like a Tiny Atmel 85. It's a very cheap microcontroller, and I will hang off something very timing sensitive of that, and then I'll connect that back to the Raspberry Pi and talk over I2C. That's kind of the approach I've done with C# and Raspberry Pi. And if you do build them, then please contribute back into the IoT libraries. But keep in mind, you must read if you want to do that, do keep an eye on the guidelines, because they do rule that with an iron rod in terms of ensuring that quality in the device drivers conform to the same kind of layout, programming model. Okay, so the next thing I want to talk about is prototyping. Now, as I said before, and I started off in this talk, I suspect most of us on this talk, tuning into this talk, are probably software developers first and hardware tinkerers second. So the approach that I take is that I tend to use pluggable boards where I can get away with it. And the three that I kind of used for Raspberry Pi, I've got Grove sensors, which can be super useful, and I'll show you those in a moment. Another set of pluggable kind of off-the-shelf sensors, one you may not have heard of, is called Micro. It's from a company called Microelectronica. And they have a series of boards called click boards. And again, they've got a great range of sensors that you can add on there and actuators you can add on there. And off to the right, we've got things like the Explorer Hat Pro. I really like this board. So if I want to go and use a wire and just wire something up and put a sensor on that, it's super easy to go and do that. You can wire up LEDs and temperature sensors and various things you might want to go and do. It's also got built into it an analog to digital converter. You can do just basic GPIO input. It's got I2 SPI on there. And it's also got an H bridge or two H bridges on there. So you can go and drive motors. And one of the demos I'm going to show is how you can drive using that board, just a very simple way of going and driving motors from C#. Okay, so the next thing I want to talk about is some of the development environment. So what I'm going to show you is going to be using Visual Studio Code, using C# and .NET. And Visual Studio Code, if you're not familiar with it, it's kind of an extremely popular open source IDE for developing code in, or writing markup documents in for that matter. It's extensible and you can basically go and add in extensions. And the extension I'm going to be adding in is the C# extension. Now, I just want to make a little note on this because you may be very tempted to go off in a particular direction. At the moment, the C# extension is only supported on Intel x86 and x64. So even though Visual Studio Code is now supported directly on the Raspberry Pi. And if you've got a Raspberry Pi version 4 and you've overclocked it, then actually Visual Studio Code is actually a pretty decent experience. But you cannot use the C# extension because there is not an ARM build at the moment. And that will invariably change, but not setting expectations. But the general principle plan is that we have good support across ARM and Intel. Okay, so the environment I'm going to be using is .NET version 5. Now, if you hadn't caught up with some of the naming changes, be aware that we used to call things .NET Core, so it was .NET Core 1, 2, and 3. And then with .NET version 5, it's kind of a unification of the .NET framework and .NET Core. So what's happened now is that what you might have thought was .NET Core version 5 is now just called .NET version 5. In fact, I think it's actually technically called 5.0. So if you'd lost track of that, just keep in mind that what .NET 5 is now is really the unification of .NET Framework and .NET Core. And we jumped to version 5 because we didn't want to have confusion with the .NET Framework version 4. If you weren't confused, you probably are now. Okay, so as I mentioned before, we're going to be using the C# extension. And we need to install .NET Core version 3 or 5. I would suggest you go and do version 5 onto your desktop machine. Now, this will work whether you're using Linux, macOS, or Windows. So that link to those hands-on labs that I showed you before, they will work. This will work across Mac, Linux, and Windows. On Windows, you need to install WSL, which is the Windows subsystem for Linux. So just keep in mind there's that. And there are a number of different deployment options. There's what's called a framework-dependent deployment. So a framework-dependent deployment is when you go and install the .NET Core runtime on the Raspberry Pi itself, or you can go and do what's called a self-contained deployment, in which case all the bits that are needed for that application are all bundled up into one directory and they are deployed onto the Raspberry Pi. And the way that we're going to deploy these apps to the Raspberry Pi is going to be using rsync. Now, for Windows folk, you'll know that there is no rsync on Windows, but there is on Windows subsystem for Linux. And on Mac there is, and on Linux there is. And then what we're going to do is we're going to attach the debugger. Now, what I forgot to go and show is just something about these boards. So remember on this slide up here, I mentioned that these are some prototyping boards. So up on Seed Studio, you'll find a stack of different sensors. Really, as much as you can imagine, you will probably find up there on Seed Studio. All different things. They could be speakers, they could be lights, it could be temperature sensors or whatever. And obviously the beauty of these is it's super easy to get up and running without having to be an electronics expert. The other one I mentioned is the click, so the micro click boards. And these, again, are a lovely set of boards that they'll work on Raspberry Pi, they'll work on STMs, on Azure Sphere. So the great thing about both the Grove and the clicks is you can tend to use them across your projects, across different development environments you might have run. And again, you'll see a whole range of sensors for these. Now, what I strongly recommend is that you go check first before you go and buy these. You go and check to make sure that there is a driver, or figure out how you're going to write a driver. So if you go to the click boards up here, for example, if I just go and click on there for more info, certainly the click boards, I think it's the same for Studio, for Seed Studio, I should say. Down here, they will have, no, I can't find it. They will have the libraries. Yeah, here they go. They will have the driver libraries. Now, you're not going to find a C# one there, but as I said, you will find a C one there, and it's pretty straightforward to go and bring those across into C#. And the last one I mentioned was the Explorer Hat Pro. Yep. Alrighty. Okay, so we mentioned .NET Core, change the name, run the Visual Studio Code. We're going to run that on our desktop, Linux, Mac, and Windows. We need to install .NET Core onto our desktop. We need to install the software developer kit onto our desktop because we're obviously going to build apps, and we're going to deploy these apps with Rsync. And the way this is going to work, we've got Visual Studio Code, and we're going to use Rsync and push that across to the Raspberry Pi. And then once that's completed, we're going to attach the debugger. Now, the beauty of Rsync is what that would do is, you remember we said we are going to use a self-contained deployment. Now, the first time you go and deploy that will be about 30 megabytes of .NET framework files plus the application. Then when you use Rsync, what it will do is it will just ship over the differences. So it gets to be super efficient. And I've tried both ways. I've tried it. Do I go and do a framework deployment, or do I go and do a self-contained deployment? And I found in the end, the self-contained deployment was probably the easiest. It's also easy because you don't have to go install .NET framework onto the device. There are some kind of advantages and disadvantages, just so you know. If you did what's called a framework-based deployment, so this one here, so you've got the .NET runtime on the device, it means that when you patch that framework, you're patching it once. It also means that when you go and deploy an application across onto the device, it's smaller because you're not having to send the whole framework over. So it's pretty quick. The upside of doing a self-contained deployment is you don't have to worry about any dependencies. You don't have to worry about what version of .NET framework, or if any .NET framework is already installed on the Raspberry Pi. You don't have to worry about that. The downside of self-contained is, should you need to go and update the framework, then you need to redeploy the application onto the platform again. So those are kind of the trade-offs. Alrighty, so what I'm going to do is we're going to jump into some code. I'm just going to give you a very quick demo. So as I mentioned before, this is the repo where the samples are. And in fact, if you go into, so there's basically talks all the way through how to go and set these up, how to go and configure your .NET Core, talks about the IoT libraries, and you'll see that there is how to create your first Raspberry Pi C# application. And we go through here, and there's a bit about installing Visual Studio Code, updating your Raspberry Pi so it's all up to date. And then we need to go and set up security. Now, I've already done that. Basically, what you want to be doing is you want to be able to get an SSH key. So when you're syncing up files, you don't have to worry about being prompted for passwords. It's just straight through with Rsync. So all that's on there. And the other thing, if I just go back one layer, up here, there is a directory called samples. And as you can see, I kind of got quite prolific probably about 6 months ago. And there are a whole stack of samples in there, which I kind of felt covered off a whole range of scenarios. And you can see that I've kind of updated some of these quite recently. So they should be pretty good to go. Now, I put a few more that are kind of a little bit more specialized as well. So for example, you may see that if you need to be able to build a .NET Core application, for example, that might want to go and grab an image, and then you want to send that image up to, let's say you want to send it up to Azure IoT Hub or IoT Central or whatever it might be, or for any cloud platform for that matter. If you want to send an image, then you kind of got a couple of ways to do it. You could either base64 it, which tends to be a bit painful because it kind of blows up the size of the data packet you need to send backwards and forwards. Or you can go and use things like Google Protobuf. And Google Protobuf is a binary serialization for things like images, or where you've got larger binary objects that you need to be able to ship across. So you'll see that I've done examples in there for .NET Core and Raspberry Pi. The other one that I've done is for Avro. And Avro, again, is quite a popular protocol if you want to be able to ship around particularly larger binary objects. So those are kind of the more specialized ones. The rest of them there you'll find something called DPS, stands for Device Provisioning Service. So that basically means that that application has been set up to assume that there is a device provisioning service set up. Device provisioning services are therefore what we call zero-touch deployment. So you can basically, if you were a manufacturer or something, you might go to a manufacturer and say, hey, look, I want these devices. And they would pre-configure them for your network. You'd come along, plug them in. They would talk to the device provisioning service. They would exchange certificates and say, yep, I know about you. I'm going to grant you access into the IoT hub. It's the kind of general idea behind it. And there's this one over here, which I'm going to show in a moment, which is called PNP. So it's called PNP. In fact, it's called DPS, so for Device Provisioning Service, IoT, PNP. So the PNP in this case is for IoT Plug and Play. And I'm going to talk about what that will look like as well. So as I said, all those samples are up there sitting up on my GitHub, and feel free to raid and give these things a whirl. Alrighty, okay, so just so you can see what I've kind of got here. So you'll see that I've got a couple of Raspberry Pis. Hopefully that's coming up on my screen now. And in fact, I'll jump back to what I'm hoping should be 50-50. Alrighty, so what I've got here is I've loaded up the project. So you'll see it's C# project. And what I'm going to do, you'll see on the device, you'll see that it's got an 8x8 LED matrix on it. And yep, you guessed it, we're going to make them sparkle. And it's kind of fun. It kind of tests your maths a bit as well. You can generate random numbers, and then it's all about sines and cosines. In this case, what we're going to do is make sort of like a rainbow pattern. The reality is you're not going to see that because when it fires up, the camera is going to get overglared and it'll just look a bit like a blur. But anyway, you get the general gist of it. So that's the code there. And why don't we go and set in a, yeah, it's going to start off a thread on this application. Then we're going to put a breakpoint on this thread. And what I need to do is I need to go and modify the launcher. In fact, before I go into that, I just want to talk about a couple of things. So the first thing is the project file I want to talk about. So if you've done any .NET Core development, you'll be familiar with adding in package references, typically off NuGet. And you'll see that the first one I've got here is the IoT.device bindings. Now I'm using the PySenseHat, and the device driver for that is in that namespace. So you'll find it in, I can't remember the exact namespace for it, but it sits in that namespace to get pulled down. We use units.net for things like converting temperature to Celsius or Kelvin or Fahrenheit or whatever it might be, color space and things like that. And then the other options I'm going to look at is up here, and this is something I've played around with just of recent, of using property groups and conditional property groups. So you can see at the top of the property group, the first thing we've got up here is that the runtime identifier is Linux-ARM. So Linux-ARM will target Linux ARM 32-bit. Okay, and then we've got some conditional property groups, and you can see we've got in here, we want the debug symbols. We wanted to go and do full debug. We're going to use the latest language. And we don't want to optimize. We want to be able to see what's going on when we're stepping through the debugger. Okay, so that's what's happening in the proj file. So standard CS proj file. The next file I'm going to talk about is this thing called the launcher. And you're familiar with this. This is the kind of thing that you use to basically kick off, typically use it to kick off a task and then attach a debugger. So what I'm going to do is I'm going to kick off what's called a pre-launch task. And what this is going to do, it's going to build a debug version of the application and then publish it, do a publish build of it with .NET. And then it will do an rsync, and I'll show you that in a moment. The next thing you need to go and do is down here, this is the credentials that rsync is going to be using for the Raspberry Pi. And as I said, I've done the SSH, and we're not going to be prompted for password. So the first thing you need to go and do is change that. And in fact, the one I'm going to be pushing this on to is a Raspberry Pi. So it's user Pi at Raspberry Pi 3A. And just go and change them all and do the same in tasks. Okay, so up here in the launcher, I've got two launchers. I've got one for debug, and you see I've got another one down here for release. And if I go and look in the tasks, you'll see that this is the label. So if you're not played around with this before, that's a label. It goes looking in the tasks for a task which has the same label. And what that's going to do, it's going to shell out, and then I'm going to run .NET publish, which is going to build a publish build for the application. And if you scroll across a bit further, what I'm going to do then is concatenate, and then I'm going to concatenate that with rsync. And you'll see that there are various things in there. I think V was for verbose, and I think I'm probably doing some compression and things like that. And then what I'm going to do is I'm going to copy this across to the Pi using that login. And if I go across to my Raspberry Pi, hopefully you can see that I'm on the wrong Raspberry Pi. So the only file in that directory is, try and make this a bit bigger, is the VS debug, which you need to install before you can do any of this. Just so you can see what the device is, NeoFetch is a kind of a useful tool. And you can see that this is the Raspberry Pi Model A version 1. It's been up for a couple of hours. You can see what clock speed it's running at, how much memory. So this is a half a gig device. Alrighty, so remember there is nothing in there except VS debug. Okay, so next thing I want to do, and what I also recommend, actually, this is more probably applicable to me because I've been playing around with 64-bit and 32-bit, and that kind of can get a bit confused, the bin directories. So over here on the debug taskbar, I can select the build I want to go and use, debug, release. So you can also click on down the bottom, down the taskbar, and I can go and select debug. And that'll kick that off. And then what that'll do is that will kick off the build process, and you'll see, ignore that, you'll see that it copied over 31 meg over to that, and that's just happening over my wireless directory, over my wireless network. And you'll see it's at the breakpoint, and if I go and do ls on the Raspberry Pi, I can go change directory, .NET, and ls all, and you can see that there go all the framework files that got copied across. Okay, so we've now got everything on there, and you can see that we've hit the breakpoint. And you can do this just like desktop development. You can step through the code. We'll do a console write, and we'll see that the temperature. Now, what I'm doing is I'm grabbing the CPU temperature. I'm using the CPU temperature because you don't need any special sensors to have this demo up and running. And this will sleep for 2000 milliseconds, so 2 seconds. Alrighty. Now, you probably can't see that too much, but you'll see in the camera, the device camera, I'll make that a bit bigger. It's just bursting too much color into the lens for the camera. But you can kind of get the general idea is that application is now running. So really, it's pretty straightforward. And you will find these task files, there's the launch file and the task files, you will find those in the samples plus what you need to go and do. And here we go, we've got an application. So we've got the device, so we're using IoT device SenseHat, which is that Pi SenseHat. And the other device I'm using is the CPU temperature. It's just a sensor just built into the Raspberry Pi on the ARM chip. And if we scroll down here a bit further, we will see that here we are. I'm creating a new instance of the SenseHat, SenseHat pressure and temperature. And you can go and do things like, hey, look, I'll go and set a, actually, no, what I had in mind is probably not going to work in this example. Anyway, you kind of get the general idea behind that. So that is the first app of which I deployed. and you can go and do restart and stop the application and things like that. If I just go and push that, if I go and redeploy that application, you'll see that the application gets sent across, and this time it goes across really quickly because we're not having to send the full 30 meg across. And as you'd expect, you can go and look at variables and stuff like that and set watches, and it's the kind of usual stuff that you want to be able to do on .NET Core for C# applications. Alrighty, okay, so the next thing I want to talk about, so that was kind of like Hello World Rainbow. Okay, so the next thing I want to talk about, and I've got a couple of examples about how this works. We're going to talk a bit about IoT Plug and Play, and what is it? So IoT Plug and Play is trying to solve the problem of having devices out there which have multiple different capabilities that talk different languages, they use different schemas, all those types of things. It's an attempt to standardize on the way in which you go and describe a sensor or a device. And in this case here, what I've got is I've got a Raspberry Pi with some sensors on it, and I've got a model that I'm going to describe it. So I'm going to describe its properties, the type of telemetry it can send out, the schema for that telemetry, and potentially what commands you might want to go and set. And it's a JSON definition, and it's an open source specification, and it's also built on this thing called JSON-LD. So there's a lot of use for this definition and the schema. So the whole concept behind it is to create a standardized way of which you can go and describe sensors or devices and things like that. And then when you have a standardized way, then you can have applications which can consume that standardized or IoT plug and play protocol, or devices which have an IoT plug and play description or model ID. And to kind of give you an idea what a model ID would look like, here goes one here. You can see that at the very top, you'll see that I've got this thing called a DTMI, I think it stands for device twin model ID or something along those lines. I think I've butchered it. I'm not 100% sure that's what it stands for. Yeah, I think it is actually device twin model ID. And you can see that there goes the model ID. So you can see the model ID for this model here is Glovebox HVAC, and it's a version 1. And you can see down through here that there's now a JSON document that describes the telemetry in this case. So you can see this is telemetry, it's temperature, it has a display name of room, and it's going to return back telemetry of double, and its units Celsius. And you can see another one down here, which is telemetry, pressure. Hey, look, it's ambient air pressure. Schemas double, and the unit is HPA. So that's the kind of concept behind an IoT plug and play device. It's a device that either you've created or you've gone off to a manufacturer and said, hey, look, does your device support plug and play? Because I want to go and use a particular application which is plug and play enabled. And I'll show you that in action. Now, in terms of plug and play applications that are available from Microsoft today, and by the way, this is not just a Microsoft thing, so I just want to talk about a couple of applications. There's something called IoT, Azure IoT Explorer. And on my desktop down here, I've got the app here, and it provides a very useful way in which you can go and browse the devices that are connected to the cloud and look at the telemetry and see what's kind of going on with those devices. IoT Central is a plug and play platform. Plus, there are a number of custom applications or people building custom applications which can consume IoT plug and play enabled IoT devices. And the beauty of that, of course, is it means that you can go off to various manufacturers, grab a device, it's plug and play enabled. You come along and say, yep, I want that. You kind of drag and drop it into your application, and your application consumes that JSON document and says, yep, that's fine. I kind of understand that. Alrighty. Okay, so I'm going to show this demo in the context of something called IoT Central. Now, IoT Central is it's a fully hosted, managed IoT platform, kind of a platform for IoT solutions. It's customizable. You don't need to go and use web dev skills. It's just kind of a solution that you can kind of a low code, no code solution for building an IoT backend. The thing I love about it is it's a really quick way of demonstrating the value of IoT solutions. Because what can happen is you can spend a whole lot of time building out your devices, getting that connected to the cloud, and then you're going to kind of build a back-end solution. And this makes it super easy. And it's extensible with rules, and you can monitor things, and there's analytics and dashboards and stuff like that. Now, while I remember, you also can have a 7-day trial. I think it was with 5 free devices. Or if you want to take the standard edition, you can have 2 free devices that run kind of forever. So if you do want to play around with this and you're just kind of worried about, hey, look, this might just start getting expensive. 1, it's not expensive, but 2, you have 2 free devices to go and use on the standard, and the standard S1, I think it's S2. So just keep that in mind if you do want to play around with this. And it provides great ways to visualize tools and visualize and things like that. Alrighty, so what I'm going to do now is just walk through a demo and kind of give you a sense of how this hangs together. So the second app that I'm going to show is this application. This one here, you can see up here in the title, if I move the mouse around, you can see that this is the .NET Core IoT C# DPS for device provisioning IoT plug and play device twin example. And this is kind of bringing this all together with C#. And what we've got on here is, I'm going to scroll up, and you can see, if I'm going to just make this a bit smaller, let's make the font a bit smaller. Hope you can still see that. And what I'm looking for, yeah, is the model ID. Okay, so this is the model ID that this application is going to present to IoT Central. And with that model ID, there is some specification for that defined. In fact, you can see the model ID in this project. Again, you'll find this sitting up there in the GitHub repo in the samples for the sample. And what you need to do is you need to install an extension, Visual Studio Code extension called DTL, I think it is, yeah, device twin definition extension. And you'll see that I've already got that installed. And what this does is that this tool understands the schema for building out these documents. So for example, over here, if I went and hit that, if I just hit Control Space, you can see it brings me up all the valid schemas. In this case here, look, I just want double. The same thing here would apply if I just Control X that, hit that, you'll see that, hey, look, it brings up the valid units for this. So you can see that the schema is really useful because it actually helps you build out these schemas and get it right. And there is a validation process for this as well. And you can see inside this document, you can see that I've got, this case, hey, look, the name is temperature, display name is temperature. Sorry, I meant to start probably at the top. The type is telemetry. And there is a kind of like a subtype called temperature. And its schema is double, and it's Celsius. And you can see it down here, I've got something called a property. And a property is the ability to kind of set a state on the device, or you can have the device set some state in the cloud. You could say, hey, look, this is the last known state of this device. This was the current temperature in the room the last time I pushed that up to into the cloud. And in this case here, this is what's known as a writable property. And you can see it's writable because it's writable is true. And what this means is that in this case here, IoT Central and the Azure IoT Explorer will understand that this is a writable property, and then will expose a UI for you to be able to go and update that property. And you can see that there's various things down here. So that's the kind of the general idea behind these documents. It's a way of just describing what's going on with this, what's describing. Alrighty, so what I'm going to do is I'm going to bring up IoT Central. And there it goes. And what I'm going to do is I'm going to create a new device, and this device here, I'm going to call it Raspberry Pi 4.8 because it happens to be an 8 gig Raspberry Pi, though you don't need an 8 gig. This uses very little memory, so don't feel like you need we don't need to go out and buy an expensive Raspberry Pi for this. And if I go and click on that device, we'll go to connect. Now in here is the connection information. Now you may be wondering, I thought I heard Dave say that using device provisioning service that these devices would self-provision. And that is true, except in the case of the Raspberry Pi, because it does not have what's called a TPM. So it does not have a trusted platform module where you'd store a certificate in it, and then you would set up a trust relationship between the device and IoT Central and say, hey, look, I trust devices that have been signed with a certificate, in which case they would automatically go and create the device for you. So if you're just wondering why I've created that manually. So I'm going to go across to an environment file. And now the first thing I think I copied was, was a device ID, which I've already got that in there. I want what's called the ID scope. All about the same. And I need the key. And we actually only use the primary key in this example, so I'll spare you my copying and pasting. Alrighty, so what this is going to do is I'm now going to ship this across to the Raspberry Pi version 4, and I need to set the host ID, the username and the host for this. I've already set up the SSH certificate for this, and this is going to go across to a user called Ubuntu. This is the default user, and the device is Raspberry Pi 4.8. And I'll change those there, and I need to go and change them in the tasks JSON as well. Alrighty, so I've done that, and we'll flick over here to devices, and I'll just move this device out of the way. And you can see that this is the Raspberry Pi version 4 that I've got connected up. And what I'm going to do now is I'm going to F5 to run this. Okay, and that shipped that across. And alrighty, that's a name resolution problem. And almost invariably, if I go and do that a second time, it will work. If you do get a lot of name resolution problems, just use the IP address of the Raspberry Pi. You see, the first thing it's going to do is I'm going to create a provisioning object. And then what I'm going to do is I'm going to associate the model ID. So remember the model ID? If I hover over that, going to make a liar of me. There's the model ID, and I'm associate that, and then I'm going to create device registration with that. We'll take a moment. That should have done something. And we'll kill that. We'll just do that again. Run that. Hope he's not going to make a liar of me. What a breakdown there. So it does something. Alrighty, okay, so it's connected. And you'll see that the blue light has come on. So what I'm going to do now is go back to devices, and you'll see over here that the device has now been magically associated with this device template called thermostat. Now, the way that worked is that in the device template, which got automatically pulled in for this device, if I go into devices over here, go to thermostat, you'll see that, I think it's in there, you'll see that there is a view and identity. And you'll see over here, it's on a common example over the right-hand side. Now, what there is that there is a public repository of templates. Yeah. And all they are is a Git repo. And if you want to go and define your own perfect plug and play template, you go and define that. Then you submit that as a pull request on the plug and play repo, and then that's where your plug and play will be in a public repository. You can also do your own, of course. So that's kind of how that worked. So that's how I got this device. Oops. That's how the template got automatically pulled in. So you can see that there goes the application, the IoT Central application, and you can see that the Raspberry Pi C# application is now streaming telemetry to it. What I'm going to do is I'm going to extend the default template that we add, and I'm going to add in a properties form. And I'm going to add in 2 properties that were defined in that JSON document. And these are the writable, this is the writable property. And I'm going to publish that. So I saved it. Apologies, I did that quite quick because I'm conscious of time. And we'll go back to devices and we'll go to Raspberry Pi 4, and you'll see that we've now got this properties tab. And you can see what I can do now. You can see the last reported temperature is 55 degrees, 60 degrees. So if I go and set the temperature to 70 degrees, what that will do is that will send a message to the device, and the device will say, oh, I need to turn the heater on. The current room temperature is 60 degrees. I need to get it to 70, so I need to turn the temperature on. I need to go and do 20. We're going to set 20 on there. You'll see it. Hey, look, I need to turn the cooler on. So I go and flick that across to blue. So that's the kind of the idea about how that works. Alrighty, and one last demo, and this demo you can actually get to give it a go as well. Excuse me. Alrighty. So that was the demo there with using what are called properties or device twins. The next demo is just a little bit of fun, and what I'm going to do is we are going to be able to, I'll find the link. I'll put the link in the announcements. So there's a link in that I've just placed in there. So if you go and click on that link in the announcements, and hopefully someone will do that. And what I'm going to do now is I'm going to deploy, whoops, I'm not going to start up Visual Studio. I'm going to start up the third app, which is a Raspberry Pi Rover application. And what I'm going to do is I'm going to switch out my devices, and I'm just going to put this Rover on here. And I'm going to deploy the application, and this should all be ready to set up to go. So what that's doing is deploying the Raspberry Pi Rover application. So if someone has already clicked on that, okay, so that's deployed the application, and for the sake of waiting for somebody, if I go and click on forward, you'll see that that's now controlling this C# application. So the way this is working is, you can see in fact the architecture for this, and you'll find the sample is there as well. So it's a C# application, and it's running on there, and it's listening out for something called direct methods. Yay, someone's firing it up. And you can go and make it go backwards if you want to play around with it, and or stop it in this case. So what that's doing is that this HTML page is calling a Azure function, and that Azure function is then calling IoT Hub, and it's initiating what's called a direct method. And that direct method, surprise, surprise, it's got commands in it like go forward, backwards, turn left, turn right, go in a circle, things like that. So that's kind of how that application works. As I said, that application's up there, and you'll see that I'm also using GPIO. And you can see that I have set up a GPIO controller, and yay, someone's made it turn and things like that. So you can, if I just move this over, you can see that both motors are going. And I'm just going to stop that because otherwise I won't be able to hear myself talk. And you'll see the way this works is that, you remember I said that this Explorer Pro Hat had an H bridge in it for driving motors. And we've got GPI controller, and the idea behind this is you can go and open up pins for output. And I can say I want to open up for output, and I am going to stop that. I'll tell you what, I might even just stop the app. Sorry, folks. And basically what I'm doing is I'm opening up a pin for output, setting it low, so the pins are basically stopped. And then if I scroll down here, so this is the basic control here. So you can see I've got a class in here for motor, and you can see I've got a method in here for forward, backward, stop. Those are the kind of the 4 major functions. And then if I go across to program CS, you'll see I've got a collection of actions. And surprise, surprise, if I want it to stop, then I want the left motor and the right motor, those actions to stop. If I want it to go forward, I'm going to left and right motor go forward. If I want it to turn left, I stop the left motor and then I turn on the right motor and make it go forward, so it kind of does an arc. So that's the kind of idea behind that. And then I'm just getting, I've got a listener on here for commands, and I'm pretty sure, yep, that's how I remember how I did this. I just literally send 0 is stop, 1 is go forward, 2, etc. And those are just used as the index for that actions set of actions, which is defined up here, called direction. Anyway, so hopefully that kind of give you an idea, a bit of fun, and you can try that example out. And I said, I use this particular board, this Explorer Hat Pro. It's kind of a cool board. You can get it off the shelf, and it's got an H bridge in it. Okay, so in terms of resources, take a quick screenshot of this. Those are where you'll find the resources. And again, take a screenshot of this and you'll find this will get you off to the my GitHub. So remember, Gloveboxes, super easy to remember, github.com/gloveboxes, and you'll find that repo. And given I just updated it today, you'll find it's the top one sitting up there. Right, so I've been keeping an idea and questions. So has anyone, I haven't seen any questions come through. Does anybody have any questions?
We haven't had any questions come through, Dave, but what I will get you to do, I can still see the demo in the screen, blocking people from taking a screenshot.
Thank you.
So do you mind just putting those links maybe in the Q&A section for people to click through to?
Yep, sure.
Great, thank you.
Thank you.
So we haven't had any questions come through at this stage. Is there anything you'd like to finish off with?
No, I really do think that's probably it.
Great, well, brilliant. Well, thank you very much, Dave, for taking the time this evening. It was a great visual demonstration as well, so much appreciated. And thank you to everyone for tuning in tonight for another Microsoft Reactor Sydney live stream event. Wherever you joined us from today, have a good rest of your afternoon, evening and morning, and we'll see you next time. Thank you very much for everyone for tuning in. Thanks again, Dave.
Absolute pleasure. Thank you very much, everybody. Bye-bye.
Bye.